Hello once again. We're coming to you from our offices in the downtown, and there's some form of celebration going on here, probably something associated with statistics. So let's begin. This presentation 4.2 is part 2 of a series in probability. Now we want to illustrate the notions of probability. We've taken an illustrative example here, and we're going to ask you to pause the screen at any time. 40% of the students fail grade 12. 60% are involved in some form of drug abuse, and 30% are involved in both. Now, by simple subtraction, we can see here that in this yellow part must be 30%, in the pink part must be 10% rather, 40 minus 30, and out here, of course, is 100% minus the total here, or 30%. If a student is selected at random, probably failing the grade 12 is 40%. Involved with drug abuse is 60%, and drug abuse and failing is 30%. So we're going to look at the probability D or F or both. Now the correct answer here is, of course, the sum of 10, 30, and 30, which is 70%. We want to look how it's related to the probability D plus probability of F. On the right-hand side we have 100%, so why the difference? Well, the difference is simply we included the 30 as part of the failure rate and as part of the drug abuse. So we subtract it once, and that becomes the first rule of probability. And we call it the general rule of probability. We switch to A and B to denote a general application, and this becomes the general addition rule. A special case occurs when A and B are mutually exclusive. Both can't happen. If one happens, it excludes the other, called mutually exclusive. In that case, probability of A and B is 0, and that means that this expression reduces to what you see on the screen here. A simple example, if you select a card from a deck of 52 at random, probability of ace or king is simply the sum of the probability of ace plus probability of king, because ace and king are mutually exclusive events. Now we're going to look at the law of complements. The probability of not D is 40%, and we're saying that's 1 minus the probability of D. So over here, 60% are involved with drug abuse, 40% are not, and the sum of those is 100%. And in this case, probability of failure plus probability of not failure, 40 plus 60 is 100%. Therefore, probability of not F is 1 minus the probability of F. In other words, our law of complements says the probability of not A is 1 minus the probability of A. And take notes here as necessary. Now the conditional probability rule says if we have some information available, for example, if we know the student is associated with drug abuse, we know that student is one of these 60 people here, and the probability D is 30 out of 60. So that's 50%. And we write this as follows: F given D is the probability of F and D divided by the probability of D. Note that the given D part goes on the bottom. It's the denominator. And on the top are those in D that are also in F. And that's 50%. And in words, amongst those involved in drug abuse, the probability of failing is 30 of 60, or 50%. Now, given that the student fails, we'll look at the other side of it. The student is one of those 40 people. The probability of drug abuse is, of course, 30 out of the 40, and that is 75%. Conditional probability rule, then, is given on the screen here. You divide by the probability of B, and on the top is probability of A and B. And we're going to look at the conditional probability rule here and use it to compute the probability of A and B, and we simply say we're cross-multiplying here. We take probability B over on the left-hand side, and we have this multiplication rule. Here's an example. Two aces, A1 and A2. Probability A1 times the probability of A2 given A1. So it's 4 to 52, 3 to 51, and that's the answer. For three aces, we have a generalized, applying this twice, we have the following: 4 to 52, 3 to 51, 2 to 50. And that applies to our example here. D and F probability of D times probability of F given D. As you can see, there's some cancellation going on here. The result is 30 out of 100. Independent events, B given A, probability of B. So this says that the ratio amongst those of A that are in B is the same as the overall ratio of those in B. And we have the general multiplication rule here. This is the case for independence. We're going to show you that in a minute. A given B is the probability of A. Again, if this is true, they're independent. So these three boxes here associate with equivalence formula. So we're going to look at the examples here. Now pause the screen and look at your values. This is not true, so these events are dependent, and this also fails, suggesting they're dependent. And on the right hand side here we have failure as well. So F and D are dependent events because these equations are not true. Overall failure rate is 40%. Amongst drug abusers, the failure rate is 30 out of 60, which is 50%. This suggests a link between the two, and this is where we're heading. The overall drug abuse rate is 60%. Amongst those who fail, the drug abuse rate is 75%, and again, this again suggests that link. This is the end of presentation 4.2. We ask you to take notes as required and continue to presentation 4.3.